Hey guys, welcome back to DataProcs with R. In this video, we're going to continue on our word combinations analysis, and we're actually going to get into the sentiment part of word columns, or of word combinations in this. So let's just jump right back into it. Okay, so where we left off, we did these the bigrams, we mapped them, and we used stop words, we used TF, IDF, so we could kind of predict which word combinations were specific to each text to kind of give us an idea of what makes that text or what it's about. So now we can use bigrams to provide context in sentiment analysis. So let's start by doing bigrams separated. Oops. And then filter word 1 equals not, and then count word 1, word 2, sort equals true. So this was my example before with something like, I cannot spell separate. So with word combinations, if we were to look at unigrams, not would be negative, and then something like I'm surprised good doesn't come up here unless I missed it. Well, my example was good. So not is a negative score, that's a negative word, and then a word like good or no, it might be a positive word, as in K-N-O-W, not N-O. And so the combination means more than the words individually. So by doing sentiment analysis on bigrams, we can examine how often sentiment associated words are preceded by a modifier like not or other negating words. So affin, we use the affin dictionary for this. Oh, what happened there? Accidentally hit tab or something. Alright. Okay, so we pulled up our dictionary or lexicon where we have the 1 to 5, -1 to +5 scores for positive or negative, or for positive or negative sentiment. We can examine the most frequent words that were preceded by not, and associate with sentiment. So we're going to do not words, our bigrams separated, filter word 1 is double equal sign, not triple equal sign. Let's move that. Okay, is not, pipe down, inner join, affin, by equals word 2 equals word. That's a single equal sign because we're going to look for the column. Count word 2, value, sort equals true, and then we'll print our not words. Okay. Bigrams separated. What did I misspelled something, so I'm just going to copy my cheat, I said biograms. Bigrams separated. Okay, so we have not doubt. Interesting. We have, which is a -1 value, and we have that 25 times. Not like, which not like would be negative, right? But it has a positive value of 2, and that occurs 11 times. So that would really skew our analysis, right? Because we'd be giving points to like, we'd be giving 2 points to like, which is a big, double all these other ones. But in reality, it's not like, so that should be negative. So we can then examine the most frequent words that were preceded by not. So, well, actually, I just did that. Sorry, I'm losing my spot. Okay. Delete that. We're moving on. All right. So let's visualize. So library ggplot2, not words, mutate contribution equals n times the value. So we're getting the overall sentiment is what we score at times how many times it appears in the text, right? So doubt would be -25. Not doubt would be positive, but we're getting -25 to our overall score. Like is 2, so 2 times 11 is 22. We would be getting 22 positive, so good sentiment, even though it's not like, right? So we're going to graph it. That's what we're graphing. That's why we do that. The contribution equals that times values. Range, descending, absolute value of contribution. And then head 20, so we're just going to look at the first 20. Mutate word 2 is equal to reorder word 2, and we're going to base it on the contribution, not the contribution. ggplot aesthetic n times value word 2 fill equals n times value, and as long as it's greater than 0, and we're going to do a geom col, so we're going to do a bar plot, show legend equals false, because it just takes up too much room. We just want to look at it. And then our labels are going to be sentiment value times number of occurrences, and then y equals words preceded by not. And the reason that we put those backslashes in there is to say this isn't our quotation mark isn't our code. We actually want to print that in our graph. So it's called an escape. We're escaping the R designation for it and just printing those. So as you see, it's value, not values. Where do I have values? Oh, times value. Okay, so you can see down here. So we've printed not, right, with the quotations around it. That's what the backslashes do. All right, so as you can see here, these are the biggest predictors or cause of misidentification, right? So you can see that not like was a score of 20 points in the positive direction when it should really be negative, and not doubt gave us a negative 25 score when it should really be positive because it's not, right? Or not kind of flips the meaning of it. So what we can do, let's filter out negation words. So we're going to call them not, no, never, non, without, and you can add some others if you want. If you have stuff you're like, oh, that word probably does the same as not. Like dis might be one you would want to try. Negated words, bigrams, separated, and filter word 1 in negation words. So we're saying get rid of anything that we put in that negation words list there. So inner join, affin, by word 2 equals word, and then lastly count word 1, word 2, value, sort equals true. Alright, so we should get rid of anything that had not in it now. So if we look at negated words, so this is our negated words: no doubt, not doubt, no great, not like, not whatever. And you can see the times that the number of times that occurs, right? So 210 times we have no doubt occurring there. Okay, so let's visualize the negation words. Okay, so we have negated words, mutate contribution equals n times value, word 2 equals reorder paste, word 2, word 1, sep equals, and we're going to do a underscore as our separator, and then contribution. Then pipe down, group by word 1, slice max, ABS, contribution, n equals 12, with ties equals false, so we don't want to print ties, we just want 12, and I'll pick probably alphabetically after that. Aesthetic, word 2, for our ggplot, contribution, fill equals n times value, where it's greater than 0, and make it a column or a bar plot. We don't need a legend because it takes up too much room. Let's do it for each text. So facet word wrap word 1, scales equals free. Oops, no, free. And scale x discrete. Labels equals function x g sub, so global sub. Just copy what I paste here. I'm going to put a regular expression in. And then xlab words preceded by negation term. ylab. Why did that? Oh, we need that. Okay. ylab sentiment value times number of occurrences and forward flip. So this just flips the x and the y axis. So if you, I mean, it just looks better. Pass it should be paste. Now where did I misspell that? Reorder. There we go. Contribution. So I spelled it T-I-R somewhere. Contribution. There we go. Okay, so now we have each word. So our FATS is word by word, not by book, I'm sorry. So we have each word. So never, and then it tells us what the bigram is and how that affected our sentiment analysis. So no doubt really affected, it skewed stuff real negative, right? Negative 200 in our overall score. And when really we should probably get rid of it. Without doubt, and all these doubt ones. Doubt was always positive because there'd always be not doubt or no doubt or without doubt. So interesting writing quirk, I guess. Okay, so let's call it for this one. The last thing we're gonna do before we get into the Twitter stuff, which I know you're probably like, oh, this stuff, I just want to do the Twitter. And so I just want to lay the groundwork and show you how, like, it's cool to know what is possible for if you want to do sentiment analysis for your, for public health reasons. So we're kind of using some of the kind of a little bit of a deeper dive in it. It's fun stuff. It's cool, I think. It's interesting to think analytically. Like, usually we look at least in our curriculum, you have to take British literature, American literature, yada, yada, yada. So it's cool to look at a different lens by, like, instead of just reading it and from the liberal arts point of view, we can look at it and we can, like, analyze this and say, can we predict it based on the words that make this up? So it's kind of a cool idea. And to see how people react to stuff. Like, instead of, right now when I'm recording this video, it's around election time. So I'm getting all these phone calls from pollsters and stuff that are like, who are you going to vote for? Blah, 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 because they want to predict that. Well, what if we could just cut out the phone call crap and predict stuff based on what's already available on the internet? Pretty cool stuff. So the last thing we're going to do in the next video before we get to Twitter is we're going to actually make networks with these words. So we're going to visualize it in another cool way. And then we'll be finished up with that, and we'll get into scraping Twitter for tweets and sentiment analysis. So I hope you enjoyed this video. If you watched it on YouTube, please hit like, please hit subscribe. That's all for me. I'll catch you guys in the next one.